hopefully you can tell what each form is called. We're going to start with number 3. Hopefully you know this is vertex form. Hopefully you remember this is called intercept form, and this one's called standard form. They each give you special points. We're going to talk about the vertex form. It's called a vertex form because it gives you the vertex very easily. Hopefully you can tell the vertex is 3, 7. Remember, it's always the opposite of what's in the parenthesis. So that's 3, 7. So our vertex, we're going to write it nice and small down here. Make sure you write it small so you can fit it. But your vertex is going to be 3, 7. And then you go over here and you put 3, 7 on your graph. Hopefully you can do that. We're just finding our vertex and putting it on the graph. Next, I want to find the axis of symmetry. For this one, I can actually find the axis of symmetry really easily. Do you understand the axis of symmetry always goes through the vertex? So this is going to be a line right down the middle of that vertex, and that would be the axis of symmetry. So I'm going to go, okay, it's going to be a line like straight down there. And so I'm going to put axis A of S is x equals the 3. So I now have my axis of symmetry and my vertex. And we're going to, later on, in a little bit, in a second here, we're going to talk about how to graph it from there, but we're starting right now with the key points. We'll build upon more later. Now hopefully you can tell by looking at this number in front, it's your A value. Hopefully you can tell it's a vertical shrink and it's upside down. So you're going to kind of have a pudgy graph that's upside down through there. We're going to talk more about it, but you should kind of get the idea it's going to look kind of like that somehow. Anyways, we're going to go next to this problem. It's called intercept form. Does it give us our x or y intercept? X intercepts. Do you remember it's just the opposite of those numbers? So, my x-intercepts, you can call them zeros if you want. Either word's fine. My x-intercepts are 3, 0, and it's a nice looking 0, and negative 1, 0. Remember, it's the opposite of those numbers. It's always the opposite of these. And then can we put those on our graph? Put those dots on our graph. So we now have the x-intercepts. So I know that graph's going to be somewhere between those two. It's going to hit those two dots. I know it's a parabola. And look at your a value. Your a value is a 2. So that means it's a vertical stretch and it's up. So it's going to look kind of a little bit narrow, maybe like that somehow. Now, could we actually find our axis of symmetry, the line down the middle of this? Yeah. Well, can't you just kind of average those two and find the middle? This one's pretty easy to find, the axis of symmetry. It's just right down the middle. So let's draw it in. So my axis of symmetry, can you tell it's going to be just 1? You can see it visually. But what if I didn't have a graph? Can you just look at the zeros if you don't have a graph and find the axis of symmetry without the graph? So hopefully you can tell, if I average these two numbers, that'll give me my axis of symmetry. And here's what I mean by average. Watch. Average is just, if I want my axis of symmetry, all I'm going to do is I'm going to take the two numbers, negative 1 and the 3, and average them. If you compute that, you're going to get your 1. So if you just take the two zeros, x-intercepts, average them by adding and divide by 2, you'll get your axis of symmetry. Now, you know, on this problem, I can see it. My eyes work well. But if you didn't have a graph, if it just had a question without a graph, you still need the axis of symmetry. Oh, we have to take the middle of these two dots. Next, we're going to do this standard form. So to do standard form does give you a nice easy point. It deals with this right here. 5. 5 is your y-intercept. So my y-intercept is that last number. It's called C. So my y-intercept is 0, 5. And then I just go up to the graph and I put a dot there at 0, 5. Now that doesn't give me too much. I'm going to add upon that the axis of symmetry. So we have them all having the axis of symmetry. So to get the axis of symmetry on this problem, there's actually an equation you need to know. This is something you need to memorize. You'll write down right now, but it's the axis of symmetry. What you need to do is this formula. It's x equals negative b over 2a. Some of you might remember it from Algebra 1, but it's negative b over 2a. Now remember, this is a, negative 1 is a, 4 is b, and 5 is c. So if I were to take and plug it into this formula, I'll have the opposite of b, which is 4, over 2 times a, which is negative 1. When I calculate that, do you see how that would become a 2? If you carefully look at that, negative 4 over negative 2 is a positive 2. So my axis of symmetry is x equals 2. So I go over here at 2 and put my axis of symmetry. So again, I found my y-intercept. I quickly use this kind of formula, which you need to memorize that formula. It's important. You get the middle. Now, can anybody remember reflection from geometry? If this is the middle, won't this black dot reflect over to here? So can I actually get that dot too? So I'm going to reflect this dot over the axis of symmetry right there. And now I know 2 dots and the axis of symmetry. Now, if you look at your a value, it's negative 1. So won't that be a normal, no stretch or shrink, but is an upside down? So what's going to happen is there's going to be a graph that kind of goes like this. Don't draw it yet. We'll talk about more points, but it's going to look like that through there. We just kind of got a visual so far. So the next steps we're going to be doing is to add a couple more points, kind of get it kind of fine-tuned and sketch in what it looks like. If you can tell for this one, do you remember making a table? We're also going to do a table here, which is a good process, even though this is the last resort. We're going to try to stay away from tables, but it's good to be able to do it. Now we're going to find more points for this vertex form. In order to find more points, we want to look at the a value. My a value is negative 1/2. Now the a value, this is a little trick I like. It's not something you'd learn in a textbook, but it's a little trick to find a coordinate with the a value. Do you remember with absolute values? Do you remember that this was the slope of the graph? But a parabola doesn't really have a slope. It's a changing slope. So, but you still can use this. What this negative 1/2 means is from this dot, if I go over one spot, I go down 1/2, I have a dot. If I go over one spot, if I go down 1/2, I have a dot. So what I got here is a dot kind of right there. It's kind of hard to put in. And right there. Basically, I went from my vertex, I went over 1 and down 1/2. Over 1, down 1/2. It's not slope, it's like slope, but it's not slope. So my parabola would look like this now. Beautiful handwriting. And I would probably just write this. What this negative 1/2 is saying again is you go over 1. You always go over 1. And whatever the value is how far up or down you go. So I'm going to go down 1/2. So you at one value to the right and left, whatever a is tells you how far up or down that you need to go. Then I put my 2 dots, and then I have my graph. Now, looking at intercept form, I have 2 points here. Could I find the value on my blue axis of symmetry? Do you understand? Could I find the value of my vertex on the axis of symmetry? Yeah, what number do we need to plug in to the function to get the coordinate there? 1. Since my axis of symmetry is 1, could I simply take some time now and find f of 1? If I find f of 1, would that give me a coordinate on the axis of symmetry called my vertex? So let's do it. 2 times 1 minus 3 and 1 plus 1. If we do this math, we get 2 times, looks like negative 2 times 2. So it looks like f of 1 equals 2 times 2 times 2. One of them is negative. So what that be? Is it negative 6 or negative 8?
Negative 8.
It's negative 8. Now, 1 negative 8 is a coordinate. Can you go put that on? 1, -8 right there. Do you have your graph? You have enough dots to get a sketch here. It's not a V, it's a parabola. My handwriting's terrible with this thing, but you got kind of looks like that. Now, could you use your A value to get another dot? What does your A tell us? What's our A? 2. So if I go over 1 and I go up 2, does it look like I'm hitting there? From here, if I go over 1, up 2, over 1, up 2, can you see I actually have a dot right there and there, which I should hit? Just to verify. It doesn't need them since we have our 2 x-intercepts and our vertex, but if you follow your A value, it gives you 2 more spots. Now we have 5 nice little dots. It's not a necessity, but it's good to practice because this one you need your A value. This one you don't, but it's helpful. And one more thing. As you're doing these problems, you guys, do you see how this number and this number are the same? That tends to happen. When you're finding your vertex, these 2 numbers tend to be the same. You'll see. Watch for it. Watch it. You'll see it in your homework. So be observant. It'll save you some headache in the future. For our last one, our standard form, we have 2 dots there. My last point that would be helpful would be my vertex, which is on this red line. I know there's a vertex there somewhere. So, to find my vertex, I need to just plug that number in 2. So I want to find f of 2. I'm going to plug 2 into the function. So let's plug in 2. Now, the biggest problem for people is not making mistakes in their calculations. So be very careful on your calculations here. When you plug in -2 to this function, you get here 2 squared, then make it negative. You got that? You're squaring, then making it negative. Kind of think of that as a -1 out front that you multiply on after. Then 4 times 2 is 8. And the 5. So f of 2, if we add all that up, what is that going to be? 9? If you add all that up, you should get 9. Can you put the coordinate 2, 9 on your graph? There's my vertex. Do you guys see the graph? Now, before we graph it, can you actually look at your A value to get a couple more points? What does my A value tell me? Oh, doesn't it say to go over 1 and down 1? Over 1, down 1. Can I get 2 little points there to make it a little bit more accurate? So let me put a dot right there and a dot right there for my A values just to give a little bit more accuracy. Not a necessity, but just a little bit more accuracy. You don't always have to do that. But there it is. Last part is I want to fill this table in. So to fill the table, my first step is to put my axis of symmetry right there. Are we okay with that? My axis of symmetry is the middle of my graph, right? And what did I get for coordinate? What's my vertex? What did I get for 2?
9.
Didn't we get 9? Can we just write that one in? Okay, what is a value to the right of 2? Well, right here is 3. And then right of that would be 4. Okay, what's a value to the left of 2?
1 and 0.
Not 1 and 0? Okay, now, could we technically plug those numbers in? Yeah, but aren't they on the graph?
Yes.
So if you can see it on the graph and you know it because of your characteristics, just plop them in the table if it needs a table. Meaning, according to our graph, 0 what?
0, 5.
Isn't it 0, 5? And 1 what? What do we get for 1?
1, 8.
1, 8. And then 3 gave us,
3.
isn't that 8 as well?
Yes, 8.
And 4 looks like it gives us, is that 5 as well?
Yeah, 3, 5, 4, 5.
Now, if you could not see it from the graph, guess what? Plug the numbers in like we did here. Now, do you have to plug in technically all the values? No, if I know these 2, can I just mirror them over? Please be smart enough to do that. It saves you time. Do these 2 and mirror them over. And if it was your choice and you had to do a table, would you choose 0 and 1 or 3 and 4 to plug in?
0, 1.
Would you probably choose 0 and 1? because they're just easier numbers to stick in the equation. But then once you plug these in, you mirror it over. But you don't have to if you already have it on your graph.